Hello everyone and welcome to this presentation on the architecture of a CNC program. Today, we will explore in detail how CNC programs are structured and more specifically, the three essential code types, alpha, G, and M codes. These are the fundamental elements that allow a CNC machine to transform a design into a precise physical product. This is not just about memorizing commands. It's about understanding the logic behind them, how they interact, and why they are written in a specific sequence. By the end of this session, you will know how to read, interpret, and create CNC programs that are both efficient and accurate. We will start by reviewing the general structure of a CNC program. Then, look at each type of code in depth, and finally, we will go through three complete examples: a basic milling operation, a drilling cycle, and a circular interpolation cut. Along the way, I will give you practical tips and observations that you can apply directly to real machining situations. Let's begin with the general structure of a CNC program. Think about it as a carefully written recipe. Just as a recipe begins with a title, a list of ingredients, and preparation steps, a CNC program starts with a clear identification, setup parameters, and an order sequence of operations. The first line is usually the program number, greeting with a letter O followed by digits, such as O1001. This is like naming your recipe, so the machine knows exactly which set of instructions to execute. After the program number, we set up the machine parameters. This is where we choose the correct tool using the T command, define the spindle speed with the S command, and determine the feed rate with the F command. These values are critical. For example, machining aluminum requires different speeds and feeds compared to stainless steel. The wrong parameters can result in poor surface finishing, excessive tool wear, or even damage to the machine. Once the setup is ready, we move to the preparation stage. Here, we use G codes to define the measurement units, the coordinate systems, and the motion mode. For instance, G20 sets the units to inches, while G21 switches them to millimeters. G90 puts the machine into absolute mode, meaning that all positions are based on a fixed 0 point. If they use G91 instead, we will be in incremental mode, where each movement is measured relative to the previous position. Understanding the difference is essential because a single mistake in position and mode can completely change the outcome of a machining operation. After preparation, the heart of the program is the operation sequence. This is where the machine performs the actual cutting, drilling, or shaping. G codes control the movement, such as G00 for rapid positioning or G01 for control linear motion. At the same time, M codes manage the auxiliary functions like turning the spindle on or off, changing tools, or starting the coolant flow. This part of the program is where precision matters the most. The sequence must be logical and efficient to reduce machining time without compromising quality. Finally, we finish the program with a set of closing commands. This often includes stopping the spindle, returning the tool for a safe positioning, and ending the program with a M30 or M02. Ending properly is as important as starting properly because it leaves the machine in safe state, ready for the next job. Now that you understand the structure, let's go deeper into three categories of CNC codes. The first category is alpha codes. These are the letters that define the parameters of the program. They specify what to do and where to do it. Examples include O1001 for the program numbers, X, Y, and Z that indicate positions in space, T01 for the tool number, S1200 for spindle speed in revolutions per minute, F200 for feed rate in millimeters per minute. If you think of the CNC language as a sentence, alpha codes are the nouns and they name the things we are working with: positions, tools, speeds, and feeds. Without them, the machine will have numbers with no meaning. The second category is G codes. These are preparatory functions that tell the machine how to move. G00, for example, is used for rapid movement. When you want the tool to get to the position as fast as possible without cutting. G01 is used for cutting in a straight line at the control feed rate. G02 and G03 perform circular movement, clockwise and counterclockwise. G81 initiates a drilling cycle, moving the tool down into the material, retracting and repeating as needed. G20 and G21 set the measurement units. If alpha codes are nouns, G codes are verbs. They tell the machine what action to take and how to take it. The third category is M codes. These are the malicious functions that control the machine supporting actions. M03 turns the spindle on clockwise. M04 turns it counterclockwise. And M05 stops it. M06 changes the tool. M08 turns on the coolant. M30 ends and rewinds the program. And M codes are like stage directions in a play. They control everything that happens behind the scenes to support the main actions. These three categories, you can write programs that are clear, logical, and adaptable to many situations. Let's see how they come together in a real life examples. Our first example is a basic milling operation. O1001 basic milling, G21 for millimeters, G617, G90 for XY plane in absolute mode, G01 M06 for selecting and changing the tool one, S1200 M03 for starting the spindle clockwise at 1200 RPM, G00 X0C5 for moving rapidly to the starting position, M01 C-2 F100 for lowering into the material at a controlled speed rate, G01 X50 G0 F200 for cutting a straight line, G00 C5 for retracting the tool, M05 for stopping the spindle, and M30 to end the program. What's happening here is as simple but important. We set the units, define the plane, choose the tool, and start the spindle. Then we move to the starting point, lower into the material, make a cut, retract, stop the spindle, and finish. This example is basic but illustrates how alpha, G, and M codes work together. Our second example is a drilling cycle. O2001 drilling, G21 G90 TO2 M06 S800 M03 G00 X20 G20 Z5 G85 R2 Z-10 F75 G80 M05 M30 In this case, tool 2 is used for drilling with the spindle running at 800 RPM. The G81 cycle automates the process of moving to the drilling point, drilling to minus 10 millimeters, and retracting to 2 millimeters before the surface. G80 cancels the cycle. This kind of operation is efficient because the machine repeats the drilling process without you having to write each step manually. Our third example is a circular interpolation cut. O3001 circular cut, G21, G90, 303, TM06, S1000, M03, G00, X0, C5, G02, X50, G50, I25, G0, F150, M06, M30. Here the tool 3 is selected, and G02 commands a clockwise circle of movement. The I and the G values define the center of the circle relative to the starting point. This is commonly used for machining circular pockets or rounded features. To wrap up, remember that alpha codes define what and where, G codes how to move, M codes define what machine actions to take, and understanding these three elements allow us to write programs that are precise, efficient, and safe. By combining them logically, we can control every aspect of the machining process, from the initial setup to the final product. Thank you for watching this presentation. I hope that it has helped you understand the architecture of a CNC program and feel more confident in applying these concepts in real-life world scenarios.